Hello everyone and welcome to this section. In this section we're going to perform a very important transformation. This is what we call it perspective transform transformation. Okay. Again, I don't like just throwing like operations without actually having the value behind it. So in general, in self-driving cars or any applications, sometimes we have an image that, for example, looks like this, which is speed limit of 25. The problem is the image, in the actual image, I can't view the actual sign from the front in a way. I'm actually viewing it from a different transform, okay? Or kind of we call it perspective view. Okay, you're actually viewing it, for example, from below, you're viewing it from the side. And what we need to do is that we need to kind of, twist that sign and actually look at it from the front, okay? And that's what we call it perspective transform, changing the perspective of what you actually view the image, okay? All right, so how can we do this? Simply, what we need to do is that if we look at this image, for instance, first of all, we need to identify the key points, all right? What object do you need to actually have it transform in a way, okay? Or to apply that perspective transform on it. So the first step is what we do is that we identify this, what we call it source points. So here I look at my image, I look at my, like 25 speed limit sign. And what we do is that we identify point 1, 2, 3, and 4. And I'm basically asking OpenCV in a way to take these points and actually rotate it in a way and so I can actually view it or see it. All right, and that's pretty much what we expect the image to be. We wanted the speed limit to look like this. I can provide the dimensions as well of the output image. And I have to specify as well the destination points. So what I need to do is that I need to identify the source points. I need to identify the destination points. And from these two, I get what we call it an M matrix, which is simply, we use what we call get perspective transform. We provide source points of the object. We provide destination points, what I want these points to be. And then I use what we call a get perspective transform from OpenCV to return me the M matrix, okay, which we'll call it transformation matrix. That's it, in a very simple form, as if you are applying rotations or translation. Remember, we had the matrix, and once we apply the matrix, we can then use warp, okay, warp perspective in this case. We're gonna use image, we're gonna use the matrix that we used, and then we apply here, we'll provide the dimensions of the output image, and that will give me the warped image, all right? And it's actually very simple operation, but it's very critical. Why? Because that means I can simply on the fly, if I would like, for example, my self-driving car or my deep network, as we're gonna cover later on, to actually view the image and train, for example, train on different images, okay? It's better to perform perspective transformation in this case, okay? Or if you would like to test it, for instance, you can actually do this, which is kind of an important operation. The key element or the key question here, or the key problem, okay, is that I need to identify the source points. So I need to actually go there and identify the source point, which is kind of, basic in a way. What we need to do is that we need to have kind of an more advanced algorithm and actually detect the object on the fly, okay? Actually, we're gonna learn what we call it template matching moving forward, where we can actually, in the image, if I'm looking for an image of a truck, you can detect the truck and you can draw a rectangle around it, okay? And that's very interesting. Why? Because once you draw a rectangle around it, that means I know the points, then I can know the source points. Once I know the source points, I can see what destination points that I wanted to, and then I can perform the kind of perspective transformation without physically providing the source points, all right? And that's kind of the next level or the more advanced form of mixing kind of the template matching, which we're going to be covering later on, along with the perspective transform. All right. So again, just to summarize, here we are performing what we call it projective transformation. So we call it non-affine transformation, which again doesn't preserve parallel lines or the length or the angle. We're actually changing. These lines might be parallel, or these lines that actually are not parallel here. And when we shift them, we force them to be parallel in a way, okay? That's what we call it, the non-affine or projective transformation. And again, what we have done here in a very simple form, we provide the source points, destination points, we obtain the transformation matrix, and then we use the warp perspective with the matrix and the image to give me the warped image, all right? Let's shift to the Jupyter Notebook and actually apply it right away. I hope you guys enjoyed that section and see you in the next section.